Okay, so welcome to the first lesson of the first finance lesson. This is actually lesson 5. And so we're going to mainly be dealing with future value, present value, net present value, and internal rate of return. Um, Here's some links for you can see the similarities really between the financial functions in SciPy and the financial functions in Excel. Um, they they were mirrored off of when NumPy was created. The financial routines were created. Uh, they were mirrored off of Excel, so it should be very familiar to a lot of financial analysts. But we also go through the CFA program uh, fundamentals, and program curriculum to give that sense of coupling. So here's the future value formula, and we can try to do this example. Calculate the future value of a $200 investment at the end of 2 years if it earns an annually compounded rate of 10%. And so, let's bring in, let's initialize our libraries, and let's look at the future value. These are the parameters. So present value, interest rate, number of periods, fixed payment if it's there, um, and then if that payment is at the beginning or at the end. And then it returns value at the end of the number of periods period. Okay, so, and it also gives an example here. So we pass in the rate of 10%, the number of periods 2, set payment equal to 0, because this is not paying, or not making any payments. It's a lump sum, and then we do negative $200. You can see that we have FV as 242. The future value is $242. We can do the rounding because remember it's still having to deal with the issue of floating point, and so that's now we formatted it as an F string. FV is equal to $242. Okay, so next we have present value. Here's the present value formula. This is also set up in NumPy, and it's a very similar signature compared to it. So what's the present value instead of this single sum $200, 10%, 2 years? So very similar. $165 is the present value. And so this is discounting, and that's future value is compounding. And so now we can move into the net present value of cash flows. So here's the formula for NPV. It's basically taking the sum of cash flows at specific points in time, and it's using a discount rate. At the moment, we'll use a universal discount rate. So calculate the NPV of an investment project with an initial cost of $5 million, positive cash flows is 1.6, year 1, 2.4, year 2, 2.8, year 3, and then use a 12% discount rate. Okay, we can run that. So we could take a look at the signature as well, if we did for the others. It's just rate and then a values, array like, and then this is the rate is the discount rate. so it takes in 2, so it's pretty straightforward. And then it returns the NPV. It's 33, 0.33. Now, sorry, we did this in just we took out the million, so it's actually 334,000 once we get back to the correct significance. Okay, so that is the NPV of this investment project. Okay, now we can similarly calculate internal rate of return. We're essentially setting NPV to 0. But there's also an implementation for NumPy. And we can see here that implementation, it takes in values and it'll figure out, there's an example here, and it'll figure out what the IRR is. And so the IRR for this specific example is okay, so what is the IRR for the investment described in the preceding example? Okay, so we're just going to use the same numbers, same cash flows, and then so the internal rate of return is 15%. This is stuff that this is content that will show up on CFA level 1 exam, and so it's very fundamental to the certification. All right, thanks. I will see you in the next lesson.